All right, here we go. Question 23 from our Precalculus, homework number 12, in MyLab Math. They want us to write the partial fraction decomposition of the given rational expression. Let's go ahead and take this into our scratch work and get started. Now, the first thing I need to do before I start my partial fraction decomposition, I need to check the denominator and see if it will factor. Turns out it will. In the denominator, we have the difference of two perfect cubes. Now, you are going to need to know how to factor the sum or difference of cubes, and let's run through that real quick, okay? First of all, verifying that these are perfect cubes, x times x times x makes x to the third. 1 times 1 times 1 is 1, making sure those are perfect cubes. And then we can do the recipe for the sum or difference of cubes. So the recipe says we start with a set of parentheses. Notice the second set is a little bit bigger than the first. And then we're going to throw in some SOAP. SOAP will get you the signs. SOAP stands for same, opposite, always, positive. So the first sign is the same as your cubes. The next sign is going to be opposite of whatever the first one was. And the last sign is always positive. And now for the third step, for factoring sum or difference of cubes, we need to fill in the blanks. For the first two blanks, we're going to take one of each, an x and a 1. The other two x's get the next blank. The other two 1's get this blank. And then if you multiply these two together, x times 1 gives you x. And that is the difference of cubes factored. Now we can examine the denominator to see what type of factors we have. X minus 1, that is a linear factor. The second factor, x squared plus x plus 1, that is a quadratic. And it is not reducible, meaning that that is in lowest terms, but it also is not repeated. There is only one of those quadratic factors. So in our denominator here, we have a linear factor that's not repeated and a quadratic factor that is irreducible and not repeated. So now that we've identified the two factors, we now know how to set up the partial fraction decomposition. All right, here we go. Now that we have our rational expression factored, we know that we're going to have a fraction of the linear factor, the x minus 1. So we're going to have x minus 1. The numerator is going to be a, because I don't know for sure what it is. And then for the quadratic factor, you have a linear numerator. That's going to be a bx plus c all over the quadratic factor. And in this case, that is how we're going to set up to initiate the partial fraction decomposition, taking into account each one of the factors of the denominator. Next step is we need to clear the fractions. And the way we're going to get rid of the fractions is we're going to multiply both sides by the LCD. Multiplying the left by the LCD, which is x minus 1 times x squared plus x plus 1, that will cancel completely, leaving only a minus 2. On the other side, if I multiply by the common denominator, I'm going to have to distribute to each numerator. And for the first fraction, the x minus 1's will cancel, leaving a times the quadratic factor. And then when we distribute to the second fraction, the x squared plus x plus 1, that's going to cancel, leaving bx plus c multiplied by the x minus 1. And the next step is to get rid of the parentheses and combine like terms. All right, here we go. For the first set of parentheses, we're going to distribute the a. That's going to give us ax squared plus ax plus 1 times a is a. And then for the next piece of the puzzle, we're going to have to do the FOIL method. So here we go, plus bx times x gives us a bx squared. On the outside, a minus bx. On the inside, we have a plus cx. Last but not least, we have a minus c. And now we need to CLT. I've got an ax squared and a bx squared. Those are like terms. I'm going to factor out the x squared, which would leave me a plus b. Next, I've got an ax minus bx plus cx. All three of those terms have an x. So what I'm going to do is I'm going to factor out their x, and that will leave me a minus b plus c. And then I've got my constants. I've got a plus a and a minus c. Now understand, both of those together represent the constant. This is my coefficient of x. This is my coefficient of x squared. Now looking at the other side of the equation, we have no x squared, and we also have no x. So in order for the left-hand side to equal the right-hand side, the coefficient of x squared on the right would have to equal the coefficient of the x squared on the left. Well, there is none, so the coefficient must have been 0 for the x squared on the left. The coefficient of x on the right, a minus b plus c, would have to equal the coefficient of x on the left, but there is no x on the left. So his coefficient also must be 0. And then the constant, the a minus c, would have to equal the constant on the left, which is -2. And now I have a system of linear equations in 3 variables, and I can now solve for a, b, and c. Now, if you watched the last video, I mentioned that we have about 2 or 3 techniques to solve a system of linear equations in 3 variables. We have the elimination method. We have Gaussian elimination, which uses row operations. And we also have Cramer's rule at our disposal. And I think what I'm going to demonstrate this time is the elimination method. So what I want to do is I want to take these first 2 equations and I simply want to add them together. So a plus a would give me a 2a. Notice that b minus b would get those b's to cancel. And then c plus, well, nothing would be plus c. 0 plus 0 is 0. So that gives me a new equation in terms of only a and c. And now I can apply this last equation, a minus c equals -2, at which point I now have a system of 2 equations with only 2 unknowns, and I can add these together. 2a plus a giving me 3a. The c's are going to cancel, equals -2. And if I divide both sides by 3, I'm going to have my answer for a. A is -2/3. Now once I know a, I can plug back into this first equation and find b. So we're going to have -2/3 plus b must equal to 0. Moving the -2/3 over will give me a value of b of +2/3. And then I can also plug back into the bottom equation for a and find c. So here we have a was -2/3 minus c is -2. Bringing the -2/3 over makes it a +2/3. That's going to say -c equals whatever this works out to be. And using a common denominator, 3 times 2, that's -6/3 plus 2/3 is -4/3. And then if I simply change the signs on both sides, we can see that c is 4/3. And then once I know the values for a, b, and c, I can go all the way back up to the top, plug in for A, B, and C, and I'll have my partial fraction decomposition. All right, back in our MyLab math, I want you to notice that I have replaced A with the negative 2/3 that we got. That was A over x minus 1 plus bx plus c all over the quadratic factor. I've replaced A, B, and C with what we got. And that's going to do it for that particular problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.